In this video, I will show you how to implement a simple first-person shooter game in Roblox Studio from scratch. It will give you an overall idea of how to implement a game from start to finish. Don't forget to like, comment and subscribe to support. Let's dive in. I will create an empty project using the template called Village. I'm gonna save it to Roblox and name as FPS. The template terrain is quite large. Let me show you. If I expand here, select the terrain and press F to focus, it's a very large terrain. For this game, we're gonna only use a portion of the terrain. For this, go to the terrain editor, select region, and activate the selection mode. I'm gonna use this area because there are some houses here which would be nice for a first-person shooter game. I am selecting by clicking and dragging with the mouse. This much terrain looks okay to me. If I rotate it, we can adjust the height as well. I am happy with the selection. Go to the terrain editor and click copy. We have copied the area that we want to keep. Now I'm gonna get rid of the rest of the terrain. Click create and clear. It cleared everything. Don't worry, we can now go to the region tab and paste the area that we copied. Nice. We have a smaller terrain now. I can close the editor here. Now I want to get rid of this stuff here. I simply select and press the delete key to delete them. Let's delete these two. And let's select and anchor these three so that they don't fall down at runtime. If I click play, we have a nice area for playing a first-person shooter game. Sweet. Let's collapse these. The next thing I'm gonna do is to create some spawn points by clicking spawn in the model tab. We are gonna put a few of these around. Let's put one inside this house as well. When we have more than one spawn location, players will randomly spawn at one of these. Our next job is to create a character for the players. Normally, we would let players play with their own avatars, but in some games, characters are made uniform for all players to be able to apply some restrictions. We are gonna create a uniform character for all players in this game because we want all players to hold and point a gun. I'm gonna use a dummy character here for it to be simple, but you can use any character that you find from the marketplace. I'm gonna click plugins and select build rig. I'm gonna use R15 and select block rig. So this will be the character. We are gonna animate this character and it will be used as the avatar of all the players. I want to create an animation for holding the gun. To do that, I select animation editor. When the animation editor is active, if I select my character, it asks me what the animation name will be. Let's call it gun hold and create. I want the character to extend its arms and hold the gun. I don't need the motion, I only need a pose. So I will only create a single keyframe with position and rotation data. For that, I need to add some joints. Left upper arm, left lower arm, right upper arm, and right lower arm. I will only use these 4 joints to create the gun holding pose. Let's expand these and start with the left upper arm. If I select this, we can rotate the arm like this. Let's also rotate in the other axes so that the 2 hands join in front of the character to hold the gun. Let's select the left lower arm and also rotate it like this. We can move these joints as well. Now let's adjust the right arm. Rotate it. Let's rotate the lower arm as well. Let's also move these in X and Y. It looks kinda like holding a gun with 2 hands. Click on this icon with 3 dots, go to set animation priority and select action because I want this to be the dominant animation for the character. Now let's save it. Let's also publish to Roblox to be able to use it by referring to its ID. Click submit. I will copy this ID for future reference. We can now quit the animation editor. We have our gun hold animation under the dummy character. Let's give the character a less offensive name. Let's go with starter character. To be able to use this character for all players, I'm gonna put it under starter player. If I press play now, you can see that my avatar is replaced with this character that I have created and it will be used for all players. Currently, I cannot move it. For us to be able to control the character, it shouldn't be anchored. So let's select all the parts and deselect anchored. If I click play again, we can now control and move the character. As you can see, our gun holding animation isn't active right now. We need to take care of that. The active script that controls the animations can be found under our character. It is called animate. If I copy this script, stop the game, paste it, and put it under server storage, when I double click that, we can see the script that is used for controlling the animations by default. We are gonna create a very simple version of that and use it instead of this animate script in our implementation. For this, I'm gonna create a local script under start starter character script so that it is added to the character automatically. Create one and rename it as player. Let's delete this and paste our copied ID for the gun holding animation as a comment for later use. We will start by creating some references. Since this script is going to be attached to our character, we can create a reference for our character easily. Local character equals script.parent. We can find the humanoid under the character. Local humanoid is equal to character colon wait for child humanoid. Also, we have an animator under the humanoid. We are gonna need that. So local animator is equal to humanoid colon wait for child animator. The first thing I'm gonna do in the script is to disable the animate script that is active by default on all characters. I'll go local animate script is equal to character colon wait for child animate. If you remember, the script's name was animate and it was directly under the character. We now have our reference to that script. Now we are gonna destroy it when the game starts. When we destroy it, there will be no script that governs the animations, so we are gonna have our own script control the animations. We are gonna do it similar to the animate script, but in a much simpler way. There will be 3 animations: walk animation, jump animation, and gun holding animation that we have created. Let's create some variables. Local walk animation is equal to instance.new. We are creating a new instance for that. Animation. I'm gonna copy and paste twice, change it to jump animation and gun hold animation. We have a gun hold animation. We can put the ID of that here. So gun hold animation.animation ID. Animations are referred to using IDs. So it's gonna be RBX asset ID colon / and the ID that we pasted here before. The other 2 animations, walk and jump, we haven't created them. So we are gonna use the walk and jump animations that are in the default animate script. Let's go back to the animate script. As you can see, there are some asset IDs here. We are gonna use them. For the walk animation, I'm gonna get this ID under walk here. Copy, go back to the player script, go walk animation.animation ID is equal to and paste. And similarly for the jump animation, I'll go to the animate script, copy the jump animation's ID, go back and set it to jump animation.animation ID. To play these, I need to create some animation tracks as well. Local walk animation track is equal to animator, which refers to the animator under the humanoid, colon load animation. And inside, I'll use walk animation as the animation. I'll copy and paste twice. Do the same thing for the jump animation and gun hold animation. We want to directly call and play the gun hold animation so that it is played at all times beginning with the execution of this script. The other 2 walk and jump animations will be played based on the humanoid's movement state. For that, we are gonna use some of the events that the humanoid has. I go humanoid.jumping and I'm gonna connect to that with a function. And here I'll simply go jump animation track colon play. So if the character is jumping, we are gonna call jump animation track colon play. For the walking animation, we are gonna do a similar thing. I'm gonna use humanoid.running and connect to that with a function again. This time, the function has a parameter called speed, which will be automatically filled by this event. And based on that speed, I'm gonna start or stop the walking animation. If we go to the animate script and scroll down, we can see that they are using a threshold for this, 0.75. We can use the same here. If speed is greater than 0.75, then we are gonna play the walk animation. As we are gonna stop the walk animation, and we are also gonna stop the jump animation track. Let's see how it works. Click play. You can see that the character is in the gun holding pose. So our gun hold animation is playing. When I start moving, the walking animation is played. When I stop, the walking animation stops. We also have the jumping animation. Nice. We are done with animating our character. Next, we need a gun. Let's create a simple one from scratch. You can use any gun model from the marketplace. I want to see the character while creating it, so I select the starter character and move it under the workspace. To create our simple gun, click Home and create a block part. Move it up, zero out the orientation values, and scale and move it so that it looks like the barrel of a gun. Duplicate it, move it down, and scale down so that it looks like the trigger, kinda. Duplicate again, move and scale, resembling a handle. And there it is, we have a gun. I'm gonna change the material of the handle to wood and change the color to brown. For the barrel and the trigger, let's use the metal material. I'm gonna make these two children of the handle and name it as gun. I'm gonna add weld constraints to each so that they're attached to one another and move and rotate by the same amount. For this one, the trigger, I select itself and weld it to the gun. I'm gonna weld the barrel to the gun handle. If I go to the model tab and click show welds, you can see that the parts are welded to the part called gun, which represents the handle. We need to position the gun according to our gun holding animation pose. Let's go to the plugins tab and turn on the animation editor. There is our animation pose. Let's select the gun and position it accordingly. To see the animation pose again, I click somewhere on the animation editor window. A little fine tuning on the position. It looks good to me. We can close the animation editor. Let's go to the model tab and turn these off. I'm gonna move the gun under the starter character. I want to weld the gun to the body as well. So I add a weld constraint and weld the gun to the upper torso. I'm gonna put the starter character back under the starter player. Let's play. The character is holding the gun and it moves with the character. This game will be a first-person shooter, which means that we'll be playing from a view like this. You can switch to the first-person camera in play mode by scrolling the mouse wheel. When we do that, as you've probably noticed, no body part is rendered including the gun. This is how Roblox Studio handles the first-person camera by default. It excludes any body part from rendering. When we zoom out and go back to the third-person view, we can see the body parts. But when we zoom in and switch to the first person camera, we cannot see any body parts. There are some tricks for working around that. One way is to copy the parts that we want to be visible and show them on the local player. We're gonna do that now. While in play mode, I expand the workplace and expand my character. I'm gonna select the hands, lower and upper arms, the gun and the head. The head won't be visible, but it will be a good part to anchor the other parts to and change the position based on that. So whenever the head moves or rotates, all these other selected parts will move or rotate accordingly. All my parts are selected. I click anchor to anchor them and then copy them by pressing the Ctrl and C keys on the keyboard. Now that I have my copy, I can deselect anchored and stop the play mode. Now, if I go ahead and paste, we can see all the parts in the game nicely positioned. Let's create a nice hierarchy here. Select all the parts except the head and move them under the head. Let's rename the head as arms. We can go ahead and delete all these face-related stuff. We won't be using them. Similarly, we can expand the other body parts and get rid of these attachments. We won't be using those either. We want to add weld constraints to all body parts, similar to how we did with the gun. We can add a weld constraint to the left hand, then duplicate it and move under the other parts. Now let's do some welding. The left hand will be welded to the left lower arm. The left lower arm will be welded to the left upper arm. And the left upper arm will be welded to the arms, the uppermost part. We are gonna do the same thing for the right arm. Weld the right hand to the right lower arm, weld the right lower arm to the right upper arm, and weld the right upper arm to the arms. We are gonna go ahead and weld the gun to the right hand. If we activate show welds, we can see that all parts are welded together, but some welds are grayed out, meaning they are inactive. It is because these parts are anchored. If you recall, we anchored all the parts before copying. We are gonna select all the parts other than the uppermost part that we called arms, and then deselect anchored. The welds turn to green, signifying they are active. Now I want to make the uppermost part invisible. I select it and turn up the transparency to 1 so that it is not visible in the player's view. Let's select all our parts again and disable can collide and can touch. We will be using these parts for visualization only, so we don't need these properties to be active. We have finalized the arms. I'm gonna go ahead and move it under the replicated storage to be used later in the script. Now I want to add these arms to the player with our script. First, I will create a reference for the arms. Local arms is equal to game.replicatedStorage : wait for child arms. And I'm gonna clone that. I'm gonna add it to our camera by going arms.parent is equal to workspace.camera. So a clone of the arms will be added as a child of the camera. But we need to update the position and rotation of the arms during the game. For this, I'm gonna use the run service. Local run service equals game:get service run service. I'm gonna use its render stepped event and I'm gonna connect to it with a function. Inside, I'm gonna update the C-frame of the arms based on the camera's C-frame. Workspace.camera.cframe. So at every frame, the C frame of the arms will be updated based on the position and rotation of the camera. Another job is to destroy the arms when the player dies. To do that, I'm gonna use the humanoid died event. I'm gonna connect to that with a custom function called onDied. Let's create that here. Local function onDied. Inside, I'm gonna go arms:destroy. I'd also like to keep track of the dead or alive status here. So I'll go died is equal to true. Let's create that variable here. Local died is equal to false. When the player dies, we're gonna switch it to true and we're gonna use this variable later. Next, I'm gonna implement firing by clicking. For that, I'm gonna use the user input service. I'm gonna go up here and add local user input service equals game:get service user input service. Here, I go user input service dot input began, which is an event. I'm gonna connect to it with a function. And here, I can use parameters that are filled automatically. I'm gonna use input and game processed. Inside, if game processed, which is an internal event that is handled by the game engine, I'll simply return. Here, I want to check the input type. So I go if input.userinputType. If it is enum.userinputType.mousebutton1, we are looking for left click here. Then we are gonna create a ray from the gun and we'll use that ray to check if the player hits something or not. Let's call that shot ray. I'm gonna use workspace.camera:screen_point_to_ray. This function will create a ray from the mouse position away from the camera based on the camera's position and rotation. As the input, we'll use mouse position, input.position.x and input.position.y. We will use this information to check if the player hits anything when they fire a shot. We will use this in a server-side script. In order for the server-side script to know, we are gonna create a remote event. I'm gonna create a remote event under replicated storage and I'm gonna change its name to shot fired. Let's create a reference to that. Local shot fired event is equal to, it will be under replicated storage. Wait for child shot fired. I'm gonna copy this and use it here to fire that event on the server. And I'm gonna pass in shot ray as an argument so that the script knows the ray and checks if there's a hit or not. If the player is dead, we shouldn't do this. So here, I'm gonna use the variable we created before. If died, then return, meaning that we will not be creating the ray or firing the event when the player is dead. We are gonna create a server-side script to check if there's a hit with the shots. So let's create a script under the server script service here. Rename it as game manager. Inside this script, I'm gonna first get the local shot fired event. It is stored at the same place, so I go game.replicatedStorage.shotFired. If there's a shot fired on server event, I'm gonna connect to that with a custom function called checkHit. So I'm gonna create that function here. Local function called checkHit. I'm gonna get the player information by default and also the parameter I added to the event, which was the ray information. Let's call our parameter here _ray. First, let's get the character information. Local character is player.character and we're gonna create a raycast. But we don't want it to hit ourselves, right? We want to check a hit with the other objects around, not with our avatar's parts. I'm gonna create some raycast parameters. Let's call it raycast params. It is created with raycastparams.new. There are some properties of it that we can change. Raycastparams.filterType is going to be enum.raycastFilterType.blacklist. So we will be excluding some objects from the raycast calculations. These excluded objects will be raycastparams.filterDescendantInstances is equal to character. So our character will be excluded from the raycast. Here I'll go local raycast result is equal to workspace:raycast. I'll be using the origin, direction, and the parameters. So it will be _ray.origin, _ray.direction. But this is a unit vector, so it only has the length of one stat. I'm gonna increase it by multiplying it by 100. The range for our gun to hit something will be 100 stats. And finally, I'll pass in the raycast params that we have created. This will calculate if there's a hit for the raycast. So if raycast result is true, it means that there's a hit. Then we're gonna check if the hit was to another character, which will score points for the player. So here, I'm gonna create a local model to check if there's a model of the instance that we hit. So raycast result.instance, instance corresponds to the instance that we hit. I'm gonna use find first ancestor of class, and I'm looking for model here. If there's a model, it's a good indicator. This might be another character. We can go ahead and check if there's a humanoid inside the model. I'm gonna go model colon find first child, which is a humanoid. If we have a humanoid, now we are sure that this is another player. So we can inflict damage on that since it was a hit. I'm gonna call humanoid colon take damage and pass in 100. So only one shot will kill the character. For the time being, to check if this works correctly, if there's a hit with the raycast, here I'm gonna go print the raycast result.instance. Let's play. We should activate the output window to see the print lines. Let's zoom in by scrolling and switch to the first person camera. Let's hit somewhere. It says parts, terrain, nothing. It seems to be working quite well. We can comment out this line now. Next, I want to make our gunshots a bit fancier, creating an explosion effect. To be able to see, I'm gonna move the arms under the workspace. We have the gun here. I'm gonna create an attachment under the gun. Let's call it tip, and I'm gonna move it to the tip of the gun, like this. Let's rotate it so that its forward matches with the gun's forward. Under that, I'm gonna create a particle emitter. Whoa, it's a bit aggressive for our purposes. I select it and reduce the rate down to 1. Let's change its lifetime to something very small, like 0.05, so that it looks instantaneous, like this. I don't want any speed, I don't need it to move. Let's change its color to something more explosive. There we go. I don't want it to be enabled, so let's deactivate this. I'm gonna enable it myself in the script when it should go off. Let's put the arms back in its place and move it back under the replicated storage. Let's go back to our player script and create a reference to our gun. We have previously created a reference for our arms here. Under that, I go local gun is equal to arms colon wait for child gun. Now I'm gonna access the particle. Local gunshot particle is equal to gun colon wait for child tip colon wait for child particle emitter. I go down here. When I fire the fire server with the shot ray, I will also call gunshot particle colon emit. I want it to only emit one particle when the shot is fired. Let's play and see if the effect is working nicely. If I click, you can see the particle effect. Sweet. Our next job is to add some audio to our gunshot. To do this, I go to View and Asset Manager. I'm gonna upload a simple gunshot audio. We have the asset here. It is added under the arms, but I want it to be added to the starter character. So I expand it and move it under the gun here. I rename it as gunshot audio. It is located under the starter character under the gun. I want it to be played on the server side because I want it to be audible for all players in the game when one of the players fires a shot. So instead of doing this in the player script, I'm gonna do it in the game manager script. Every time we call this check hit function, I'm gonna play the audio because it should be heard whenever the user left clicks, independent of whether they hit something or not. So I go character.gun.gunshot audio colon play. If we play the game now, every time I left click, the gunshot audio is played. As you may have noticed, we have a leaderboard here. We are now gonna make it functional. In the game manager script, I'm gonna use the players service. Local players service equals game colon get service players. Down here, I'm gonna go player service.player added, and I'm gonna connect my function called onPlayerAdded to that event. Let's create that function here. Local function onPlayerAdded. We can get the player information here automatically. To use the default leaderboard of Roblox Studio, we are gonna create and use a folder called leader stats, and we are gonna create some integer values inside that. If you want to learn how to create a custom leaderboard though, you can find my custom leaderboard video on the card and in the description. Local leader stats is gonna be instance.new folder, and the name of the folder will be leader stats. The name is important here to automatically get the values inside as parameters for the default leaderboard. We are gonna add that to the player itself by going leaderstats.parent is equal to player. So every player will have a folder named leaderstats. Inside, there will be a local kills equals instance.new int value, as it will be counted with integers. Kills.name will be kills. This will be shown as kills on the leaderboard. Kills.value will be 0 when the player has just joined the game. Kills.parent will be leader stats. Obviously, we need to change the value if there's a kill. The kill happens here. I can add player.leaderstats.kills.value will be increased by 1. We may also implement our win condition here while we are at it. Let's say if a player.leaderstats.kills.value is equal to 3, then it is game over. So we are going to have a game over event and we are going to fire that event. Let's create that event here under replicated storage. Add a remote event and call it game over. Here, very similar to this line, I'm gonna go game over event and it will be game over. Here, I'm gonna fire it at all clients with the information of the player, which will be the winning player. After the game is over, I'd like to wait for 5 seconds and restart the game. Restarting the game basically consists of loading all the characters in the game and setting their kill values to 0 in our case. So here, I'm gonna use a for loop. For index and value in I pairs of player service get players. So for all players, I'm gonna do this. V load character to load the character. And I'm gonna change the kill value to 0. So v.leaderstats.kills.value is equal to 0. When the game over event is fired, I want to show a simple UI element. For that, I'm gonna go starter GUI and add a screen GUI. Let's activate the game view. I'm gonna add a frame under it. Call it game over frame. Add a UI aspect ratio constraint under it. I'll set the aspect ratio to 2. Select scale with parent size and select height as the dominant axis. I'll set the anchor point of the game over frame as 0.5 in X and Y so that it is measured from the center. I will set the position as 0.5 for the X and Y scales so that it appears at the center of the screen. We set the dominant axis as height, so the X size has no importance. For Y, I'm gonna use 0.2, meaning 0.2 of the screen. This will be our game over UI. I'm gonna add a text label here. Let's call it label. I'm gonna set its size as 1 in X and Y with no offsets. It fills the whole space of the frame. I'm gonna find and enable text scaled so that the text fills up all the available space. Next, to manage displaying the game over message, I'm gonna add a local script here. Let's call it game over. Let's start with accessing the player's service. Local player service is equal to game:get service players. Let's then create a reference for our local player. Player service.local player. Also, we are gonna create a reference variable for our game over frame, which will be the script's parent. I want a reference for the label as well, cause we are gonna change it. Local label is equal to gameoverframe.label. In the beginning, I don't want this UI to be visible, so I go gameoverframe.visible is equal to false. We will change its visibility based on the event. Let's create a reference for that. Local game over event is equal to game.replicated storage wait for child game over. If we have a game over event called on client, I'm gonna connect to it with a function and we will pass in the player information so that we understand which player is the winner based on this information. Inside, first, we are gonna show the game over frame when it is game over. So .visible is true. Then we are gonna change its label based on the winning player. If _player, meaning that the winning player is equal to the local player. If that's the case, it is great. It means that we have won. So label.text will be equal to you won. Else label.text will show the winner's name. So _player.name. And we are gonna concatenate it with the string won. Like we did in the game manager script, we are gonna wait for 5 seconds. Then we are gonna hide the UI again, because the new game will start. This should cover our game over UI. Now let's add a reticle visual UI element. I'm gonna create another frame here, rename as reticle. Switch back to the game view. Change its anchor point to 0.5. I'm gonna set its position to 0.5 and 0.5 so that it is at the center. For its size, I'm gonna use 50 for the offset values. I want it to be the same size in terms of pixels independent of the resolution. Hence, I'm using offset values here. This way, the reticle image will always cover 50 pixels by 50 pixels at the center. I'm gonna add an image label. Change its size to 1 with no offsets for it to fill up all the available space on the reticle frame. I'm gonna select both of these and change background transparency to 1 and border size pixel to 0. I go to View, select Asset Manager to upload my reticle PNG texture. Go back and select the image label. Scroll down, click the image property box and select the reticle image. I don't want it rendered over the Game Over UI. So I'm gonna set the z-index value of the reticle as 0. It will be rendered on a lower layer. I don't want to show the default mouse cursor in the game. So I go to the player script. Here at the top, I'm gonna type user input service mouse icon enabled and I'm gonna set it to false. Let's play. Scroll for the first person view. As you can see, there is no mouse icon and our reticle visual is at the center. I want it to start as a first person camera by default rather than needing to scroll every time though. It is annoying. To do that, I'm gonna select the starter player in the Explorer and change the camera mode to lock first person. If I press play, it automatically starts with a first person camera view. The force field effect at the spawn location takes a very long time. Let's shorten it. I select all spawn locations, scroll down and reduce the duration of the force field to 3. Here on the player script, I'm also gonna add the game over event, which is at game.replicatedStorage: wait for child game over. And down here, I'm gonna connect to that event. Game over event.onClient event connect and call the onDied function so that whenever the game is over, we destroy the arms. Another improvement is selecting Screen GUI under the Starter GUI here and enabling Ignore GUI inset so that our reticle image is rendered exactly at the mouse position in the game without any offset. We are almost done with the implementation of the game. Now we need to test it with multiple users. To do that, I go to the Test tab and click Start. Let's find the other NPC and kill it. It is gonna spawn at a random point. We have a range of 100, so our shots will be registered if we are closer than 100 stats to the other player. It spawned here again. We are lucky. We killed the other player 3 times, so we won. After 5 seconds, the game starts again. There we have it, a simple FPS game implemented from scratch. I hope it was fun and useful for you. I published the game on Roblox with the name One Shot One Kill. If you want to check it out, you can find the link in the description. I implemented this game for computer. For mobile, some updates such as using touch input would be needed. If you feel like you need more practice on the basics or want to get more information on the concepts used in this video, make sure to check out the other videos on the channel. Don't forget to like and subscribe to support. You can get access to the Roblox project file from Patreon if you'd like. Thanks for watching. I hope to see you in the next video.